In this lesson, we will be talking about one more scenario in which the concept of arrays and pointers go together. And this scenario is when you pass an array as function argument. Let us see a code example where we pass array as function argument and try to analyze it. I will write a simple C program in which I will write a function that will give me the sum of all the elements in an integer array. This function will take an integer array as argument. This is one of the ways to pass an integer array, an array in general, as argument. This would be the data type and this would be the name of the array. And in the main method we have declared and initialized an array named A. Now in the main method we will call this function sum of elements and pass it the array A as argument. And of course we need to write the body of this function sum of elements. I will declare two variables, I and another variable sum, and initialize it to 0. I will be used to run a loop, so we will iterate through all the elements in the array A that is passed as argument. But wait a minute, we do not know the size of this array A. Is there some way to know the size of the array? One of the ways to find out the size of the array, and by the size of the array we mean the number of elements in the array here, is to use the function size of. So if we write something like size of A here in the main method, then this will give us the size of the array A in bytes. Array A has 5 integers, and in a typical compiler, and I know for sure that in this compiler an integer is stored in 4 bytes, so size of A will return 20. If we want to know the number of elements in the array, then we can do something like divide the size in bytes of the whole array by size of one integer. So we will say size of A upon size of each integer in byte. Size of A0 would give us the number of elements in the array. And I'll write this particular line below this line, the line where we are calling the function sum of elements. Now what we can do is we could either pass the size of the array as another argument, so that would be cool, and then we can run the loop starting 0 till index size -1, and we keep on adding each element to this variable sum, and finally we return sum. And finally we will write a print statement, something like this, to print the sum of all the elements in the array. Let us now run this program and see what happens. The output on console is that the sum of elements is equal to 15. 5 plus 4 plus 3 plus 2 plus 1 is 15, so this is alright. Now what I want to do is I want to modify this code a little. I do not want to pass this size as argument here. I want to calculate the size of the array inside this function. So we will not be passing this size as argument here, so there will be just one argument, the array. So we have this array as argument, the array A, and we calculate the size here as total size of the array in bytes upon the size of one integer in bytes. Let us now run this program and see what happens. Oops, there seems to be some problem, because the sum of elements that we have as output on console here is equal to 1. It should be 15. And why is it so? To explain this behavior, I will write two more print statements. One in the function sum of elements, where I will print the size of A and the size of A0. I will be calling these two functions size of upon A and upon A0 respectively. And we will write one more print statements in the main method. It will again be the same thing, printing the size of A in bytes and the size of A0 in bytes. Let us now see the output. In the method sum of elements, size of A is equal to 4 bytes. Size of A0 is equal to 4 bytes. In the method main, size of A is equal to 20 bytes, and the size of A0 again is 4 bytes. To understand this concept, why the size of A is 4 bytes in the method sum of elements and it is equal to 20 bytes in the main method, we need to dive deep into how compiler interprets an array as function argument. Once again, I will draw this familiar memory diagram. The memory assigned to an application or a program is typically divided into these 4 parts. we have talked about this in our previous lessons. For the execution of function calls, we use stack section of the memory. This green rectangle here is our stack. Now, when the program starts executing, first the main method is invoked. So some amount of memory from the stack is allocated corresponding to the call of the main method, and this particular section or this particular part is also called the stack frame of a method. All the local variables reside within this stack frame. Now here in main method we have two local variables. One is the array A and another local variable is integer total. So around 20 bytes, if integer is 4 bytes, exactly 20 bytes in fact would be allocated from this stack frame for the local variable A, the array A, and 4 bytes for total, the variable total. And there would be some more information in the stack frame. Now when the program execution reaches this particular line where we make a call to sum of elements, then the execution of main is paused and another stack frame is allocated to execute the function sum of elements. We have talked about this call stack growth and function execution a number of times in our previous lessons. Okay, now this is a local variable. This parameter is a local variable to the function sum of elements. It is not this A in the main method. What happens when we make a function call is that the value of this particular local variable in the main method, or we should rather say the value from the variable in the calling function, is copied to the variable in the called function. So ideally we should have one more A local to the function call sum of elements, and the value of A should be copied into this parameter A. So we would have another array named A taking 20 bytes in the stack frame of sum of elements, and it would have the same value, same elements as the array A in the calling function main. But actually this doesn't happen. When compiler sees an array as function argument, it does not copy the whole array. What it actually does, it just creates a pointer variable by the same name. Instead of creating the whole array, it just creates a pointer to the data type of the array. So in this case it will be pointed to integer, and the compiler just copies the address of the first element in the array of the calling function. So let's say the starting address, the address of the first element in this array A that belongs to the main method is 200. So in sum of elements, all that happens is a pointer to integer is created, and the value in this pointer to integer is 200. The compiler implicitly converts this int A to something like int star A. That is, this A here in this particular format is not interpreted as an array, but it is interpreted as pointer to integer. So whether you write int space variable name following these brackets, or you write something like int star space A, they're both the same. We have a term for this. Instead of copying the value of the variable, we are just copying and storing the address of the variable. So we make a call by reference here. Arrays always are passed as reference parameters, and this makes a lot of sense because arrays can be really large in size, so it does not make much sense to create a new copy of the array each time. It is unnecessarily using a lot of memory. So for arrays there is no call by value, there is always a call by reference, and that's why this size of A here would give us 4 as output, because A is a pointer to integer here, while here in the main method A is an array. So this format of passing array as function argument, where we put these braces to tell that this is an array, is actually interpreted something like this by the compiler. You can put an asterisk sign here, or you can put an asterisk sign here. It's the same thing. It makes more sense to write it like this. So A is actually interpreted as pointer to integer. That's why when we pass array as function argument, there is no way to know the number of elements in the array by using a trick like this. We actually need to pass the size of the array. So I'd rather move this size calculation in the main method and pass the size. And when we run this program now, we get the output as expected. Sum of elements is 15. We should always keep in mind that a variable name which is used as an array is different from a variable which is pointed to integer. Even though the compiler gives us some privileges, like we can use the name of the array to get the pointer to the first element, like in this function sum of elements, we could say something like, to pass the first element we could have said ampersand a0, the address of the first element. But if we just use a instead of using ampersand a0, then that is allowed if a is an array. But if a is an array, we cannot do something like incrementing or decrementing it like pointer variables. With pointer variables we can do a couple of other stuffs, and if we have a pointer to the starting address of the array, we can pretty much use it like a variable name for array, because ai is interpreted as value at address a plus I. So we need to keep these differences and similarities in mind. It's a little tricky. There is one more thing. Because the array is passed by reference, we can modify the elements of the array in the called function, and it would reflect in the calling function. So let's say instead of calculating the sum total, we want to double all the elements, each individual element in the array. So our code will go something like this. I want to say that ai is now twice ai, and we will not return an integer. Let's say the return type is void, and in the main method I'll clear all this stuff, and what I'll do is I'll simply run a loop to print all the elements in the array. Okay, let us now run this and see what happens. Oops, I forgot to call the function double. I must make a call before I print the elements. Okay, let us now run this. If you see, the elements in the array A are modified. Each element is twice its previous value. Because this is called by reference, the same copy of the array A is modified using dereferencing. So this was array as function arguments. An important use case of array as function argument is when we work with strings in C. So strings in C are nothing but character arrays. This concept really becomes important in the context of character arrays. We will be talking about it in the coming lessons. So thanks for watching.